begin, we'll talk about monomials. A monomial is the product of a number and one or more variables raised to a whole number power. So for instance, this is any number, let's say 3, times a variable, let's use x, raised to a power that is a whole number, anything 0, 1, 2, 3, 4, 5. So like 3x to the 8th, that's an example of a monomial. 3x to the negative second, that is not a monomial. So to identify a monomial, keep in mind that it cannot have any of the following. It cannot have variables in the denominator or bottom of the fraction. It cannot have a negative exponent on the variable, and it cannot have fractions as exponents or a variable under a radical. The coefficient of a monomial is the number in the front of the variable. The degree of the monomial, or term as it's sometimes referred to as, is the exponent or power on the variable. So let's identify whether each of the following is a monomial. If so, we will state its degree and its coefficient. So in part A, let's focus on what is the power on y. It is 3, so part A is yes. In this situation, the degree is 3. That's the power on the variable. And the coefficient is -7. That's the number out front. In part B, let's look at the power on the variable. It's -2. Since there is a negative power on the variable, this would be a no. So we'll write no, and that's because there is a negative exponent. In part C, I have -2 square root of x. Look at x. There's a radical surrounding it, so this is also no. So no, and that's because the variable is under a radical. In part D, I just have the number 7. Think about this one for a minute. Okay, your minute's over. So think about this more so as like 7 times the variable to the 0 power. That's 7 times 1, which still has a value of 7. Looking at it now, you look at the power on the variable, it's 0, which is fine. That's a whole number. It's allowed. So the answer is yes. The degree is 0, and then the coefficient is, well, we'll just say 7. So why is monomial identification important? Well, that's because that's what polynomials are made of. A polynomial would be more than one monomial or term connected with a plus or minus sign. A monomial is just one term. 6x squared is an example. A binomial is 2 terms. 7x minus 1 is an example. A trinomial is 3 terms. 4x squared minus 6x plus 2 is an example. The degree of a polynomial is the greatest degree of any term of the polynomial. The leading coefficient? Well, it's the coefficient of the term that determines the degree. So we're going to place a lot of emphasis on that term with the highest power. When we say to write a polynomial in standard form, it means to write it in descending order based on the power on the variable of each term. So like 4x squared minus 6x plus 2, it's in standard form. It's in descending order based on the power on the variable, and the degree is 2, the leading coefficient is 4. So example 2, we'll identify each of the following by its number of terms, then we'll identify the degree, leading coefficient, and we'll even write the polynomial in standard form. So first start off in part A. How many terms do we have? Well, 3. 3 means we have a trinomial. Now let's look at the term of highest power. That's -2t squared. This means we have a degree of 2, and it means, still focusing on that term's coefficient, it means the leading coefficient is -2. Now let's talk about standard form. I have a second power, first power, no power. That is standard form, 2, 1, nothing. So it's already in standard form. So already in standard form. Looking at part B, still 3 terms, still a trinomial. Look at the term of highest power. That's positive 3x cubed. The degree would be 3. The leading coefficient, since it is the term of highest power, is 3. With regard to standard form, what is it? Well, the 3x cubed has to come first, then the plus 7x, there's a positive 7, and then the minus 1 in the end. Alright, part C. It has 4 terms, so it's not a monomial, it's not a binomial, it's not a trinomial. In general, we just say it is a polynomial. The highest power term is the z to the 7th, so my degree would have to be 7. Now the leading coefficient, remember when there's nothing in front of a variable, it's like saying there's a 1 there. So my leading coefficient is 1. And then let's talk about standard form. Obviously the z to the 7th does come first, but then the plus 6z to the 4th, plus 6z squared, and then plus 2. So that is identifying polynomials and listing lots of information about them. To add and subtract polynomials, we'll literally just combine like terms. Remember, like terms would be the same variable raised to the same power. Our goal in this subsection is to distribute, drop parentheses, combine like terms. So in part A, there's nothing to distribute to either set of parentheses. So I rewrite it without parentheses, and then we combine like terms. I have a minus 3x plus 7x, which is 4x. 1 minus 2 is negative 1. 4x minus 1 is the answer. In part B, there's nothing to distribute to the first set of parentheses, but the second set there's a minus or a minus 1. So in part B, we have 4x squared minus 3x plus 3. Distribute the negative 1. Negative 1 times 2x squared is negative 2x squared. Negative 1 times 7x is negative 7x. Negative 1 times negative 1 is plus 1. Alright, do a little bit of cleanup here. Combine like terms. I have a 4x squared minus 2x squared, which is 2x squared. I have a minus 3x minus 7x, which is a minus 10x. And 3 plus 1, plus 4. Last one, part C. We've got 2 things to distribute here. 2x times x is 2x to the second. 2x times plus 1 is plus 2x. Negative 3 times x squared is negative 3x squared. Negative 3 times 4x is negative 12x. Negative 3 times negative 5 is plus 15. Combine like terms. 2x squared minus 3x squared is negative x squared. Plus 2x minus 12x is negative 10x. And you follow through with the plus 15 at the end. And that's your answer for part C. Well, I hope you enjoyed. Thanks for watching.